So far, everything we've done has been in a two-dimensional plane, the x and y plane. So today we're going to learn when we have three planes. So we have an x-axis, and it's right here. You have to imagine that it's kind of sticking straight out of the paper towards you, and it's kind of out in the air. The y-axis is the one that's flat on the paper, and the z-axis is the one that's going straight up. So we have ordered triples x, y, and z instead of just x and y. So we're going to practice graphing this point, but before we do that, I'll show you how we move. The x-axis moves this way if it's a positive number, and it moves backwards if it's a negative number. The y-axis moves either to the right if it's positive or to the left if it's negative, and the z-axis moves up if it's positive or down if it's negative. So let's try to graph this point right here. The instructions here are pretty good. The first thing we're going to graph is the x. So we need to move 3 units forward on the x-axis. So here's the x-axis, and we would just start right here, and we'd move 1, 2, 3 units out. Okay, this isn't going to be the final point, but this is where we're going to pick up when we move the next part. So the next coordinate is the y, so it's positive. So we need to move 2 units to the right because that's on the y-axis. So remember our blue dot that left off right there? We're going to take that, and now we're going to move 2 units to the right, and we're going to leave off right here. And we moved 2 that way because it's along the y-axis. See how it's kind of parallel to it? And it was positive. The last thing we need to do is plot the z-coordinate. It is 4. So from the green dot that we left off at right here, we need to move 4 units straight up. So the z-axis is up and down, so we pick up right where we left off at that green dot, and we move what looks to be 4 units, given our scale, straight up, and that is the final answer right there. That red dot is 3, 2, 4. So just to recap all on one graph, if we were to do this all at one time, we'd start in the middle. We'd go forward on the x-axis 3 units. We went right on the y-axis 2 units. And then we went up on the z-axis 4 units, and we ended right there. And that's the final place. Go ahead and try these 2 as your example problems. This one is going to move back. All right, so here's the x-axis. It's going to move this way 2 units. The y is positive, so that means it's going to move to the right 3. So kind of over that way. And then the z is positive, so that means it's going to move up. So you'd move up 1 unit. And hopefully you end right there. All right, I'll let you try number 2 all on your own. We can have systems with as many equations and variables as we want. So far, we've only been using 2 equations and 2 variables. Today, we're going to use 3. So it works best if you use elimination or substitution. Graphing gets a little messy because you can see what it's like to just graph a point, and we're not going to learn how to graph equations. So we're going to have 3 equations with 3 variables. And the solution will be where the 3 planes intersect. So just like before, they might intersect in one point. If that's the case, then our answer will be in the form x, y, z. So let's give these a try. If you can do elimination with 2 equations, you can do elimination with 3 equations. So the first thing I'm going to do is I'm just going to number them 1, 2, and 3 so that I can refer to the 3 equations. And all we're going to do is use 2 at a time. So let's pick 2 that look like we can eliminate one of the variables. So what I'm going to start with is first we're going to get rid of the negative 2y and the positive 2y. Let's get rid of those first. So we're going to use equations 1 and 2. So I'm going to write 1 and 2 so I don't forget which ones I'm using. And I'm just going to write x plus 2y minus 3z equals negative 2. And I'll write 2x minus 2y plus z equals 7. So we're going to get rid of the y's because plus 2 and minus 2 cancel out. We are going to add these two together. So 1 plus 2 is 3x. Negative 3 plus 1 is negative 2z. And negative 2 plus 7 is 5. All right, so far we used equations 1 and 2. Let's use two different equations and get rid of the other y. Since we already started by getting rid of the y's, we have to also get rid of this y. So I'm going to do that by this time using equations 2 and 3, because this has a minus 2y, this has a plus y. I know if I can multiply this 1y right here by 2 and multiply all the other terms by 2, that I'll get those y's to cancel out. So let's rewrite those right over here, right next to our numbers. First, I'll recopy equation 2. I'm not changing anything about it. 2x minus 2y plus z equals 7. Now I'm doubling everything in the third equation, and maybe I'll even put a 2 out here, because this is 2 times the third, just so we know. So it'll be 2x and plus 2y plus 4z equals negative 8. So I'll add these two equations up, and just like on the first time, these y's are going to go away. So I have 2 plus 2, which is 4x. I have 1z plus 4z, which is 5z. And 7 plus negative 8 is negative 1. All right, so all the y's are gone. And now I have two new equations, this one and this one, and they both have an x and a z, an x and a z. So now we have to figure out which we're going to get rid of. Should we get rid of the x's or should we get rid of the z's? Well, I could turn the 3 and the 4 both into 12. They both go into 12. Or I could turn the negative 2 and the 5 both into 10. And I think I'm going to do that because we already have this one's negative. So to turn negative 2 into 10, I'm going to multiply it by 5. So I'm going to multiply everything in this equation by 5. To turn this 5 into 10, I'm going to have to multiply it by 2. So I'm going to multiply everything in this one by 2. And we'll write the two new equations over here. So 3x times 5 is 15x. Negative 2 times 5 is negative 10. And 5 times 5 is 25. Now for this equation, 4x times 2 is 8x. 5z times 2 is 10z. And negative 1 times 2 is negative 2. So let's add these two equations together, because this time the z's are going to cancel out. So we have 15 plus 8, which is 23x. 25 minus 2 is 23. And we'll divide both sides by 23. And x equals 1. Great. We have one number for our final answer. We know so far that x is 1. So if we know x, that means we can take it and plug it into either this equation or this equation to solve for z. Why don't we plug it into the bottom one for x? So I'm going to take it and plug it in right there. So we have 8 times 1, because that's what x is, plus 10z equals negative 2. So 8 times 1 is 8. Recopy the rest. we will minus 8 from both sides. So we have 10z equals negative 2 minus 8 is negative 10. And when we divide both of these sides by 10, we get z equals negative 1. So now we have a second part. Now we just need the third letter, which is y. So we can go back to any one of the original equations and plug in our 1 for x and our negative 1 for z and solve for y. It looks like this third equation might be the easiest. It really won't matter. You can plug it into any of the 3 original ones. So if we have an x, that means that it's just going to be a 1. Then it's a plus sign. And then our y, which we do not know. And then a plus sign. And then 2 times z. So we're going to plug in the negative 1 that we got for z. All of that equals negative 4. So we have 1 plus y minus 2 equals negative 4. So 1 minus 2 is negative 1. So we have y minus 1 equals negative 4. And the last step is to add 1 to both sides. And we get y equals negative 3. So now we have the third letter we need, and our final answer is going to be the ordered pair x, so 1, comma, y, so negative 3, and z, so negative 1. And that's the final answer. My advice on the next example is to start with equations 2 and 3, because if you subtract them, you'll be able to get rid of this z and that z. So that's what I would do first. And rather than taking up space to rewrite them, I'm just going to forget that the first one's up there for a second, and I'm just going to go ahead and subtract. So I'm going to put a big subtraction sign out front so that 1z take away 1z cancels out, and I'll subtract everything else. So it's going to end up like this. 2 minus negative 3, that's going to be 2 plus 3, so 5x. 3 minus negative 4, so that's going to be 3 plus 4, which is 7. The z's are gone, and 1 minus 4 is negative 3. Great. Since I just used equations 2 and 3 to get rid of the z's, I need to use either equations 1 and 2 or 1 and 3 to get rid of this 2z. So since we're trying to get rid of a 2z with a 1z and a 1z, it really doesn't matter which 2 equations we use. So how about we use the top 2? How about we use equations 1 and 2? First, I'll recopy 1, so negative x plus y plus 2z equals 7. And what are we going to have to do so that that 2z and that z cancel out? If you're thinking multiply everything by 2, you got it. So multiply everything in the second equation by 2, which will leave us with 4x, 2 times 2 is 4, 6y, 2z, and it'll equal 2. So now we need to subtract those 2. So 2 minus 2 cancels out. And we will be left with, let's see, negative 1 minus 4. That's negative 5. 1 minus 6, which is also negative 5. The z's canceled out. And this equals 7 minus 2, which is 5. Great, so now we have this equation with x and y in it, and this equation with x and y in it. So, I don't want you to think that those are negative signs. I just put right there. So why don't we put those 2 right underneath each other. So I'm going to move this one over. I'm going to write the negative 5x minus 5y equals 5, right underneath the one I previously had written, just to save space. Let's see if you can take it from here. The fact that this is positive 5 and this is negative 5 and those are going to cancel out, that means you'll be able to add those two equations together. So keep going. You're going to figure out what y is. Use that to figure out what x is in one of those two equations. And then you can take your x and y and plug it into either one of those three equations to solve for z. If you finish the rest of that, you should get 1 for y, negative 2 for x, and then keep going to solve for z. And your final answer, you should get 2 for z. So the final answer is negative 2, 1, 2.